In part 2 of this lecture, I will continue discussing the basics of utilizing a Linux system. In particular, I'll talk about file ownership, file permissions, listing running processes, finding libraries used by a program, determining the absolute path of a program, and discuss the role of the superuser on the system. First, we'll start with file ownership and permissions. Each file on a Linux system is going to have an owner, a group, and access permissions. This information can all be found by running the ls command with a -l argument. It is possible to change which user on the system is the owner of the file using the chown command, or change owner, chown. The change group, chgrp command, allows you to change which group a file will be associated with. And permissions for a file can be changed with the chmod, or chmod, for change mode command. Each file has 3 types of permissions for each of the 3 levels of access. Access controls are set with a bitwise OR of permission bits. A value of 1 is used for execute permissions, meaning that the file can be treated like a program and executed directly. A value of 2 is used for write permissions, meaning that someone could change or delete a file. And a value of 4 is read permission, being able to read the contents of a file. Individual file permissions are supported for 3 classes of user: the owner of the file, members of the group with which the file is associated, and so-called world permissions, or all users on the system. Changing file permissions can be done with the chmod command, and by example, a file can be set to be world readable and executable, but writable only by its owner using the command chmod space 755 space the name of the file. A file could be set to be write protected and readable only by the owner and group by running the same chmod command, only with permissions 440. In the first example, 755 means permission 7, which is 4 plus 2 plus 1, meaning read plus write plus execute, for the owner, that's the first number of the 3. The first 5, the second number of the 3, sets permissions for the group, which is 4 read plus 1 execute makes 5, and the same 4 read plus 1 execute for the world, which is the third number. In the 440 case, the 4 means read only for the owner, the second 4 means read only for the group, and 0 means no access whatsoever by people who are not members of the group with which the file is associated. Permissions on a directory work slightly differently. If a directory has execute permissions, the contents of the directory can be traversed, allowing access to readable files and subdirectories within the directory itself. Read permissions on a directory are necessary in order for a directory to be listed. But for someone to obtain a directory listing with ls, they must have both read permissions and execute permissions for that directory. Files can be deleted on a Linux system with the rm command. Rm is short for remove. Entire directories can be deleted using rm-rf and then supplying the directory name to delete. This can be an extremely dangerous command if run incorrectly. For example, running rm-rf/ as the root user will delete every single file on the system, and it will not ask first. This will leave the system in a destroyed state. There is also no undelete function on most Unix file systems. Once the rm command has been used, the file is simply gone, and unless that file has been backed up, it is not easily recoverable. When working with a Linux system, it's often useful to see what programs or what processes are running on the system. There are two commands that can be utilized in order to find this information. The first of these is the ps command, which stands for processes. ps space AX will allow you to see all processes currently running on the system. To find out which user owns each process, run ps space AUX. The top command is a useful command for getting current information about the state of the system, including running processes, amount of available memory, and amount of CPU that's being utilized. This command displays the processes that are using the most CPU time and updates itself every second or two. This command can be exited by hitting the Q key. To see what dynamic libraries are used by a binary program, not a script, but an actual compiled binary application, one can use the LDD command. So if one were to run the LDD command on, for example, /user/bin/events for systems that have the GNOME PDF reader installed, one would find out which dynamic libraries were needed in order for that application to run. It's also possible to find out the absolute path name of an installed program to see where it actually resides on the file system. This is done with the which command. For example, typing which events should display /user/bin/events on most Linux distributions, provided of course that software is installed. Finally, there is one administrative user on the Linux system called the super user that has the account name root and has privileges to read, write, or delete any file, change system settings and install software, and perform other administrative tasks that are normally forbidden of ordinary users. On some Linux distributions, such as Ubuntu, and on Mac OS X, the root user is disabled by default. However, many other distributions, including Red Hat Enterprise Linux, CentOS, and Arch Linux, leave the root user account enabled. On systems where the root user account has been disabled, or on systems where the administrator would like to disable the root account, the sudo command allows authorized regular users to run a command as the super user. So for example, we could find the listing of root's home directory by typing sudo ls/root. To switch to the super user temporarily on one of these systems, sudo su- and entering the user's password would allow the user temporarily to become the root user, even if the root account is disabled. On systems where the root account is enabled, su- has the same effect, except that root's password must be entered instead of the user's password.